On December 3, 2015, after 10 years of design, construction, and testing, the LISA Pathfinder satellite was ready to launch.
We actually said goodbye to the satellite when we last saw it in Ottobrunn, before it was packed into the transport box to be flown to Kourou. And then finally in Kourou, that was a strange feeling to see the satellite sitting on top of such a huge pile of explosives, because that's what it is. A rocket is a huge pile of explosives, and sometimes you think for a moment, how would it be if that burns off not in a controlled way, but all at once?
And my horizon was the next hour, right? The risks were so high that you try not to think too much forward, right? But the expectations were high, and we were confident to have a mission, that the mission would have been a reasonable success.
And then came the launch.
While the start is controlled in Kourou, it was carefully observed at the European Space Operations Center ESOC, which will take over flight operations soon.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top, allumage et décollage.
It was a picture book launch in the middle of the night, in pitch dark night in the middle of the jungle, also a very special feeling. You see a light flash, you hear a dark roar, feeling the energy that's in that rocket, and immediately it's overhead and then disappears out into the clouds. And you know it will not come back.
LISA Pathfinder has started its journey on Europe's smallest launcher, the Vega.
The rocket behaves perfectly, the spacecraft is in a good shape. It's just a start. There's a lot of work to come, but it was a very good start.
And it started with waiting for a first sign of life from the small satellite.
The low Earth operations phase of LISA Pathfinder was probably the most complicated one that ESA has ever flown. The Vega launcher is a rather small one, and we really filled it up. That means there was no margin, and the launcher could not immediately make us leave the attraction of the Earth. Vega propelled us into a rather low elliptical orbit around the Earth.
Pathfinder's journey needed perfect timing in its elliptical orbit around Earth to be on a high-precision track, while staying clear of the International Space Station and getting through radiation belts with the highest hurdles right in the beginning.
And personally, I think terrified is maybe not too strong a word, but I was both excited and scared at the same time that, one hopes nothing will go wrong. In the end, it was a beautiful launch, very smooth, but these are scary moments. We managed to get through 2 of them this morning, both the launch and the acquisition of signal. That means we now have a mission.
Yeah, so we've been looking for gravitational waves since the 1960s, and the original detectors were very large bars.
There were several critical moments to come after this. The most critical was probably more than 80 minutes after the launch, after LISA Pathfinder had rounded the Earth once and came out of the Earth's shadow, and we knew that the satellite would cool down during this long round, and there had been doubts about the thermal balance of the satellite, and we were all crossing our fingers, but all worked beautifully.
Very carefully planned set of maneuvers.
The spacecraft now needs to perform a sequence of 6 apogee-raising maneuvers, providing a velocity increment of more than 3,000 meters per second.
The final orbit-raising maneuver will push Pathfinder and the propulsion module out towards Lagrange point 1. There's a transfer phase of a few weeks, during which time various pieces of equipment will be switched on, commissioned, checked out, verified for functionality.
So LISA Pathfinder is safely en route to its destination, 1.5 million kilometers from Earth.
There's never been a mission in this field detecting gravitational wave from space. So usually, not all missions, but usually missions carry telescope, cameras, spectrometer. This mission carries 2 bodies that have to free fly perfectly as Einstein would have liked them to fly, and this is completely new at the level of precision never attempted and impossible on ground, and so a big bet.
But keeping the spacecraft up there is like balancing a pencil on its tip.
Here it's really unique that we hand the mission to the scientist and ask them to tell the mission operations people what commands to send up.
It was and it is a risky mission, right? Because it's nothing that has been attempted, and most of it you cannot test on ground, otherwise you wouldn't have a LISA Pathfinder, you would have flown directly LISA. So there was an intrinsic risk, but it's very hard to push science and technology without taking risk. So we tried to retire all the risk we knew of and then jumped. It works.